Good day, guys. Today I will show you how to solve for a um, tangential and normal components of a load in a triangular block. So, by the way, this is the book that I am using, Engineering Mechanics by Ferdinand L. Singer, second edition. So, um, I already draw the problem. This is the sample problem that we got from the book. So this is the problem here and the figure. So number 206 problem state that the triangular block shown in figure problem 206 is subjected to the loads P with magnitude of 1,600 pounds and force F with 600 pounds. If AB is equal to 8 inches and BC is equals to 6 inches, resolve each load into components normal and tangential to AC. So the answer is already given, so we or I want to show you the how to get those answer. So as you can see, we have this triangular block with the force P going to the right and force F going downward. So we are asked to solve for the tangential force and the normal force of each load. So first we would like to solve for the angle because it is not given and it is important to in our equation later on. So first we will solve for the angle. So we have a given of 8 inches and 6 inches. So equals to 8 over 6. So theta is equals to 8 over 6 or 53.13 degrees. 53.13 degrees. So if you if you don't know what are the forces or where are the forces that we are looking for, so it states that we will get the force tangential and normal tangential to a member AC. So if you extend this force to there, here, and the normal force would be the perpendicular force of member AC or the line AC. So in this case, this force will be our normal component. So we will denote this by Pn, normal force. So the P tangential components of load P would be here. The force that touches the line AC or tangent to line AC and this will be the tangential components of P. So these two, we are asked to solve for these two components. So as you remember from my previous videos, I will attach the link so that you can review the previous or the related topic. So you can review, and you can also catch up more easily. So first, we in this problem we would also like to make a relations. So we would like to make a triangle, so we can perform a the or we can use the definition and the function of cosine and sine. So given these three forces, we can make a triangle. So first, we have this 1 6 1 6. So P is 1 6 going to the right. So if you follow the positions of those forces, so we can come up with a right, we would like to come up with a right triangle. So this is the this would be the PT, or the tangential force or component of P. So PT, and going down right. So, and this is the P N, or the normal component of the P. So as you can see, this is the this is a 90-degree triangle. So by P of with the P as the hypotenuse, so we already solved for the theta. So theta is the, if this is theta, this also would be theta. So the theta is from the angle from PT and P. So so this would be the theta. If you look at this in this view, so this is the theta. See, we would like to in my case, I want to use this angle here, so I would like to solve for it. So the theta 1 is just equal to 90 minus the theta. So it would be 90 minus the theta. It is 36.87 degrees. You can use also the just the theta or the angle from P to T, PT, but I find it confusing because I am used to use the angle here. So by solving for the tangential force, if you are so used in the sine and cosine functions, so you can easily solve for these two unknowns. So I am always writing this somewhere in the paper, so I will not be confused. So if I am solving for PT, I am using the sine function. So sine theta is equals to opposite, so the opposite is PT over the hypotenuse of 1/6. So transpose PT is just equal, by the way, this is theta 1 because we are using this angle here. So PT is just equal to 1/6 times sine of 36.87. So it is equals to 1/6 sine 36.87. So it is 960 pounds. 960 pounds. So, and for PN would be the cosine of this. We would use the cosine function to solve for PN. So PN cos theta 1 is equals to PN over 1/6. So PN, or the normal components of the load P, would be 1/6 cosine of 36.87, or equals to 1,279, or we can say it's 1 to 80 pounds. So again, if you want to check if your values are correct, you can always use the Pythagorean theorem, because as you can see, the resultant here is just equal to the hypotenuse of the right triangle. So P should be equals to 1/6. So it should be 960 squared plus 1 to 80 squared. So 960 squared plus 1 to 80 squared. So as you can see, that the values are correct. So it is 1/6 pounds. So this the values of the the tangential force and the normal force, the normal components and the tangential component are correct. And also let's compare it with the book. Yes, here, as you can see there, it is 1 to 80, the normal component, and the tangential is 960 here, and the 1 to 80 normal. So next, we will solve for the normal and tangential force of the force F. Just like the previous force, we want to extend the force to the member AC, because the problem state that we are asked to solve for the force tangential to that a particular line. So this is the tangential of force F. So it is Ft, and you can still put here second line for Fn. So again, we can still make a triangle, so we will not be lost, because making triangle will make us visualize the problem easily. And so that is the technique there. So first we will draw the if we have this and this, yes, if we have this F here going down, so this is F 600, and this is PN or FN rather, FN. So this is the PT, so or FT, or the tangential force going, of course, down left. So this is the FT, so this is 90 degrees. So just it is confusing, this view, so I would like to make it more just to turn it. So this would be just like this. So this is 90 degree, this is FN, this is the F, so 600, and this is the FT, and this would be what is the angle. So if this is the theta, this would be theta 1, and this is 90. So the angle from angle F and the angle FT is theta 1. So F and FT, so this is theta 1. So this would be, this is angle theta 1. So in our case, the angle FT and F would be the theta 1, and this would be the angle theta. I will just recheck. Okay, FT. Oh, that's correct. So now we have this triangle here, and the SOHCAHTOA begins. So looking for FT, we would like to use for the sine function. So sine theta would be equal to FT over 600. So FT would be equal to, so our theta here is equals to the first theta, of course, the 53.13 degrees. So 600 sine 53.13 is equals to 600 sine 53.13. It is 479.99, considered to be 480, right, pounds. So for Fn, still we would like to use for the cosine function. So cosine theta equals to Fn over 600. So Fn would be 600 cosine 53.13, or it is 360 pounds. So again, we would like to check if our values are correct. So 600 is equals to f equals to the square root of the squared of these two components. So 480 squared plus 360 squared, it should be equal to 600. So let's see if my solutions are correct. So it is correct, 600 pounds. So our values are correct. The normal force of N, the normal force of F, and the tangential force of F. So let's see if it is the same on the book. So it is here. So as you can see, 360 and 480 here. 360, 480. So 360 and 480, tangential and the normal force components rather. So that's how you solve for the tangential and normal components of a load or a force. That's all. So let me show you the full solution so you can review it, and please, if you notice some error and mistake in my solution and in my explanation, please don't hesitate to comment so I can correct it and to avoid making the same mistake in my next problem, so we can all learn. So thank you for watching, and please, if you have time, please subscribe, and thank you.